Mr. Abbott here. Time for another boring science explanation. This time we're going to be going through air masses and fronts, part of topic 7. I'm using the notes pages that were distributed in class. Air masses are important. The movement of air masses is one of the major ways that we try to predict or forecast the weather that we're going to get in the future. As you can see from the definition, an air mass is a large amount, a large chunk, a large body of air that has similar temperature and moisture characteristics throughout. The question is, how do air masses form? When air gets stuck or stagnated over a surface for an extended period of time, it begins to pick up the characteristics of that surface. If the air is over the water, it tends to pick up more moisture. If air is over, a polar region, it gets colder. Our weather really changes when we move from one air mass to the next. Okay, and that movement from one air mass into another is referred to as the passage of a front. So when we look at the chart on the bottom, there's information on the reference tables about this as well on the weather map information, but you name air masses for the location where they form. The location where they form is referred to as the source region. Okay, our latitudes really aren't source regions. They really are mostly north or south of us. Now, the symbols, air masses either start with a lowercase m or a lowercase c. Those stand for maritime or tropical. Maritime air masses are going to form over water, and essentially because of the evaporation, maritime air masses are moist. Continental air masses form over land. Okay, they tend to be dry. So the first part of an air mass is either a lowercase m or c. The symbols for tropical, polar, and Arctic are going to be capitalized. They always go second. Tropical means it forms at lower latitudes. Okay, and tropical air masses are definitely warm. Polar means the air is descending from higher latitudes. That makes it cold. Arctic means that it's forming at the highest latitudes, and Arctic air masses are extremely cold and extremely dry, so they're very cold. One thing about Arctic air masses is we really only get those in the winter. Now, the easiest way to visualize this is to look at a map like this of different air masses. You see that you've got the outline of North America in the background. The air masses tend to move from west to east because of the prevailing winds. All right, now, right through the middle, we're not really looking at air masses forming here. They're forming to our south or to our north. Any of the air masses that are coming from the south are going to be tropical. Any of the air masses that descend on us from the north are definitely polar air masses. The two in the middle, in this case number 2 and number 5, would be continental polar. So this is a continental polar air mass because it forms at land, over land, at high latitude. This would be a continental tropical air mass. Okay. Up here, you'd have maritime polar and maritime polar. Down here, you'd have maritime tropical and maritime tropical. If you're looking for examples of source regions, usually for maritime tropical, what they'll probably say is for a maritime tropical air mass, The Gulf of Mexico would be an outstanding example, the Caribbean Sea. For Continental Polar, they might talk about central Canada. Now, what are the characteristics? We can do that on the chart. So, when we're looking at this for characteristics, so the characteristics, Continental Polar would be cold and dry. Okay, as we said, central Canada. Maritime Polar would be cold because it's polar, but it's cold and moist. Continental Arctic is coldest and driest. This would be air that's descending from, say, the Arctic Circle. Usually Continental Arctic is only going to be observed in the winter only. Maritime Polar, you might get maritime polar air masses coming from the North Pacific Ocean, say off the coast of Alaska. All right. Continental tropical, maritime tropical. Continental tropical, continental means dry, tropical means warm. So this would be warm and dry. Like this, the Southwest United States, New Mexico, Nevada, Arizona, parts of Mexico, air that comes from that region would be considered continental tropical. Maritime tropical would be warm and moist. And I said, the Gulf of Mexico is the classic location where you would get maritime tropical air masses coming from. Out of these, continental polar tends to give us high pressure air because it's cold and dry. Maritime tropical air masses are really warm, wet air masses that would definitely give you warm, moist air, which would definitely give you low pressure. All right, now when we go to the next page, on the next page, air masses lead us into fronts. Okay, different air masses do not mix very well because air of different densities doesn't tend to mix. There tends to be definite boundaries. Three-dimensionally, it's a surface, it's like a bubble, but if you look on the surface, a front represents a line. All right, when you're considering warm air meeting colder air, what you're going to see is the cold air always stays down and the warm air rises. So one of the things that frequently happens along fronts is you get some type of precipitation and definitely cloud formation. So we're going to go through the different fronts. We've all experienced the passage of these. There are symbols that they use on the weather maps for various fronts. So over here, I'm going to draw the symbol for a cold front. Okay, a cold front has triangles. Okay, but the question is, which side is the cold air on? So what I'll look at is, I will look at a station model behind the front and a station model ahead of a front. When we're trying to identify fronts, we'll see that usually on opposite sides of the front, you have air with completely different characteristics. Okay, if this is a cold front, the cold air is behind the cold front. So you might get a temperature of 24 degrees on this side, and you might have a temperature of 48 degrees on that side. Clearly, the air has different characteristics. Not only that, this might have a temperature of 24 and a dew point of, say, 10. So the temperature and the dew point are far apart. That's very cold, dry air. Okay, the winds on this side of the front are probably stronger, and you can see from the wind shaft that these winds are going to be pushing that frontal boundary towards our second city. Now, over here, this might be 48 and 40. This air is warmer and moister. Not only that, if we looked at the wind direction, the winds might be coming from a completely different direction. So I've got warm, moist air, which is moving parallel to the warm, cold front, but the cold, dry air is going to be pushing this line. This cold front is going to be sliding towards the other city, and when that front hits, there's definitely going to be a drastic change in the weather. A side view. All right, so that represents this Earth's surface. Let's call this City A and City B, and I'm drawing a line from City A to City B. So here's City A, here's City B. Maybe they're separated by 100 miles. You can time how fast the front moves. I've got A in a continental polar air mass and B in a maritime tropical air mass. Right here, this point where the air masses meet on the surface is going to be a line, and that's going to be the cold front symbol line. But honestly, you get a very steep front, and you have the cold, dry air pushing into the warm, moist air. So at a cold front, cold, dry air pushes into warm, moist air. Okay, so this is cold and dry. It's got a higher density. This side is warm and moist. It's going to have a lower density. So whenever you have a front, the less dense, warmer, moister air is forced aloft. So we're going to get clouds right on the edge of our cold front. And you get a particular type of cloud, usually called a Cumulonimbus Cloud. Okay, you know that rising air expands and cools. So if you're in my class, you're going to say RAEC, or race, or rec, or whatever you want to say. This will be cloud base, where the temperature hits the dew point. But that's the typical way you'd see a cold front drawn. If we're looking for a forecast for a cold front, as the front approaches, cloud cover will increase. Okay, the skies get darker. When the front hits, you've got short, heavy precipitation. You get a temperature drop. The winds tend to shift. Okay. Cold fronts are really rapid, heavy downpours that last for, half an hour long. Okay, in the summer, you frequently see this. There's a line of thunderstorms that you can see moving at you, and those thunderstorms are associated with the cold front. Now, after the front passes, you get clearing skies, higher pressures, and lower temperatures. Once you move into the continental polar air mass, it's going to clear up, and probably the day is going to be nice. Okay, it may not be the warmest, but it's cold and dry, and there's very little chance of precipitation. So that's where I'm going to cut this segment of the video. That essentially went over air masses and fronts. The fronts are the boundaries between air masses. Fronts are typically where you have rising air and cloud formation. So the next video, we're going to go over stationary fronts, warm fronts, occluded fronts, and get into the mid-latitude cyclonic storm system. I hope this helped. Take care.